Okay, class. So tonight we are doing this numerical methods, and it is a numerical methods for differential equations. All right. So let's start with our summary. First, we must see what problem we are solving, right? So we are actually solving this simple problem here. We are just solving first order initial value problem. Okay. Yeah, just first order. Let me change the color here. Okay, right. So this problem is like that. It is y prime equal to function of xy. So of course, y prime means dy dx, right? And then here function of xy. Well, it's just a function of xy. And then subject to this initial condition. Okay, so this is the initial condition. Y at x0 is y0. Okay, so here the x0 and the y0, they are constants and they are known. All right, so even this function of xy, this is also known. All right, so we want to solve this initial value problem. Now, what do we mean by solve? Now, when you say you want to solve initial value problem, it means that you want to find the y. Okay, you want to find out what is the y. Now, in numerical methods, what we can find is we are not able to find the y, the expression. The expression we are not able to find. All right. So what are we doing in numerical methods is actually something like this. Okay, so you see the drawing here, right? So here, this is my x-axis. Now let's look at our initial condition, right? Y at x0 is y0. All right, so we actually know this point here. When x is x0, the y value is y0. All right, so this is the point x0, y0. Okay, now for numerical methods, what we do is that at the point x1, you see the x1 here, right? You just want to find the y value. All right, so maybe you go and get the y value here, and this point will be what? Because the coordinate here will be x1, y1. Is it okay? Yep. Yeah, so that is what we do in numerical methods. So in numerical methods, actually, we just find the value y1. Okay, the y value at x1. Cannot. So likewise, we also go and find the y value at x2. Then we go and get this point here. Okay. Now, all these y1, y2, y3, and so on. So these are our numerical solutions, right? So one thing to note is that all these y1, y2, and so on, the value of y at x1, the value of y at x2, all these, they are not the exact solution, all right? They are just approximate. Yeah, so they are just approximate solution. Okay. Then another thing to note is that I write all these x0, x1, x2, right? So these are the x values that you want to find the y value, right? Are they arbitrary? No, they are not arbitrary, okay? They are all equal distance. So what I mean is that, okay, between this is the distance, right? This distance is h. So similarly, from x1 to x2, the distance is also h. All right, so any two x value, the distance is h. Now, this h got a name. All right, so this h actually is called step size. Is it okay? Yeah. So what we do is that we just find the y value at all these x1, x2, x3, and so on. Okay. Yeah. So the problem seems quite simple, right? Okay. I want to go to the previous page. Okay. Yeah. So this is the problem that we are solving. And what I'm saying is actually here. So we are looking at all these x values here. So in general, xn is x0 plus nh, all right? So that's how you get your x1, x2, and so on. All right, so any two consecutive x, the distance is h. Yeah, so this is the step size h. So that's the distance between any two consecutive x. Is that all right? Okay, so next you'll go to some notation. Yeah. Okay, so we will have these two notations here. So the theoretical solution at xn we'll just write it as y bracket xn. Right? So this y bracket xn is the exact solution. Okay, and the solution that we find by numerical method, that's the y value at xn, right? So we'll just write it as a y subscript n. Okay, so this is the numerical solution. So this one exact solution, this one numerical solution. All right. So of course, this exact solution is approximately equal to this numerical solution. I mentioned to you before, right? Our numerical solution is not exact, it's just approximate. Oh, okay. So now we go and look at the how do we get all these yn, okay, the value of y at xn. So there are three methods that we learn. So the first one called Euler method. Okay, this is the expression of the method. This is a formula. Okay, this formula also appears in our exam appendix. So you no need to memorize it. Okay, so you see this one is actually very easy to use, right? So to get the y value at xn plus 1, what we do is that we just use this formula here. Okay, right? So it's just like that. Yeah, any questions about this formula here? Do you all know how to interpret this formula? Is it okay? Hey, maybe I just elaborate a little bit now. Now this fxn,yn, you know, this one. What is the meaning of this? When they write fxn comma yn, what is the meaning? What is the meaning? You have your function xy, right? Yeah, your function is fxy, correct? So when they write fxn comma yn, that means in your function fxy, what do you do? Anyone? Yeah, class, anyone? It's important that we know how to interpret the formula. Class,
you're just using the x and y for the respective function.
Well, I don't know whether you mean what I mean or not.
Like it's like for example, you're using x1 and y1 for obtaining y2. So,
yeah, I know. I mean, yes, I know. What I mean is that this notation, when we write f bracket xn comma yn, what is the meaning? That means in your function fxy, what do you do?
You function of x and y.
Yeah, your function fxy is given. So you are given this function, right? So how do you go and write down this f bracket xn comma yn? What's the meaning?
You're rearranging your equation. I mean your function.
Oh, no. Actually, the meaning is very simple. That means your x, you go and substitute xn. And then the y, you go and substitute yn. That's the meaning. Okay, not? Well, maybe this one.
All right.
Maybe this question too simple already. You all don't know what I'm asking. So actually, this is what it means. Okay, so this Euler method. Then we go to the next method. This is called improved Euler method. So that means it's an improvement, right? So more accurate. So here, if we see how we get your next y, actually this is a formula, right? So you see yn plus 1 plus y equal to yn plus half, and then you got a plus b, and then you got a equal to this, right? And then your b equal to this. Okay, so that means before you go and do this formula 8, you have to pre-calculate your a and the b. Is that okay? All right. Yeah, I forgot to show you all this diagram. Just now when we are doing Euler method, right? You know this is how we do this. Now how we tabulate is like that. See, Euler method is very easy. You just tabulate your xn here, and then of course you've got your n column here, and then your yn. Well, that's where you do your calculation. So you put all your yn here. Okay, so just like that. And then, yeah, we were talking about this improved Euler method, right? So improved Euler method 1. Now, improved Euler, not this one. Improved Euler method 1 is this. All right, so you notice that because you need to calculate the a and b, right? So it's like intermediate value. So you see when you tabulate that time, you also need to tabulate the a and the b, right? So other than n, xn, yn, right? then you also need to put in your A, put in your B. Okay. So this is a second order method. Okay, just to ask you a simple question. Once again, how would you write down this thing there? Just now this fxn, yn, you know already, right? Then what about this f bracket xn plus 1 and then comma yn plus a? What is the meaning? So in this case, you have your function fxy, right? How do you write down this one there?
You just change the variable to those variables.
Actually, these are not variables. This will be
I mean the input. Yeah.
This will be the values. So that means your x, you go and substitute xn plus 1. Then your y, you go and put yn plus a. Okay. All right. So I think this is important. Everybody understand this kind of notation, right? Okay. And then we have the next method. This is our third method. Well, this is the most accurate one. So well, we see here, of course, accuracy comes with a price, right? There's a price. You want simple, then not so accurate. You want accurate, then not so simple. Okay. So you notice that, here to get to the next y, you actually need to calculate what? You need to calculate A, B, C, D. All right. So this is your A, B, C, D. And of course, you look at them. I think now you understand all these notations already, right? Yeah, so that means your x, you substitute this one, your y, then you substitute all this. Okay. So for this one, Runge-Kutta method, this is how we tabulate it. All right. So you think not this one. This is the Runge-Kutta method. So you have our n, xn, yn, and then your intermediate values a, b, c, d. Okay. So this is how it is. All right. Okay, perhaps we go to the first question now to see how we apply all this method. Maybe before we go, let me show you a diagram. So it's on this side. Let me show you a diagram. Yeah, there's a diagram here. Everybody can see this diagram or not? Yeah, everyone can see this diagram. Maybe cannot. All right, so now everyone can see this diagram here, right? Here it is showing you the different methods, showing you how accurate is the solution. Now here we are actually solving this initial value problem. So this is the first order differential equation. Okay, and then here they plot the solutions obtained by different methods. I see this pink one, right? Can you see Euler? Can you see this Euler or not? And this pink one, right? Euler. See this is the pink one. That's the Euler method, right? Now, where is the exact solution? Exact solution actually is this one here. Okay, that's the red one, right? Yeah. Everyone can see this red one or not? That's the smooth line here. Yeah. So you can see this Euler, the solution from Euler actually looks like quite far away from the exact solution, right? Because not so accurate. And then this one here, now this one is actually our improved Euler method. Okay, that's the green one, right? So if you look at the green one, you can see it's getting closer to the exact solution already, right? And then you look at this, this one, this is our classical Runge-Kutta. All right, so it's olive green, right? You see the olive green one, it's really, really very, very close to the exact solution already, right? So this diagram actually illustrates to us the accuracy of each method. Okay, so Euler is the least accurate, very simple to use, but least accurate. This Runge-Kutta, complicated, but it's very accurate. Okay, right. Yeah, so let me go back here. And let's go to our first question. Okay, this is our first question. All right. Yeah, first question here. Consider the initial value problem. Okay, so this is our initial value problem. Now let's check with our initial condition. Okay, this is a problem that we are solving, right? Y prime is function xy, yx0 is y0. Okay, now let's match it to this problem. Okay, so this is what we have. Y prime is equal to function of xy, right? And then we have y at x0 is equal to y0. Okay, this is our initial condition. Right, so this is what we have. All right, so this will match this in this problem, the problem that we are solving to this question. Okay, so if you do the matching, what can you say? We need to identify the function f. Okay, we need to identify the x naught, we need to identify the y naught. Okay, so these three things you need to identify: fxy, x naught, and y naught. And what can you say? What is your function xy? Class, what is your function xy? Tell me. Yeah, anyone? Hey, class, you're still here or not?
Yeah, the 1/2 y over x and minus x over y. Yeah, is given.
Yeah. So it's this one, right? So your function.
Yeah.
So everyone very clear, right? Then your x naught, your x naught is what?
Just looks slightly bit on the right.
No. Your x naught is what number is this?
Oh, it's 2.
Yeah, you mean this 2?
Oh, no. On slightly bit on the left.
Okay, so it's this 2. All right, so this x naught is this 2. And our y naught here, actually is this 2 here. Well, it happens to be 2. Okay, so this is our x naught, this is y naught. So we want to use all these three methods with a step size h equal to 0.2 to find y at 2.6. It's okay? Right. Now let me go to here. This is my Euler method, right? So let us before we go and write down the method, so we know that this is our table, right? So let us go and fill out, the x first. Yeah, because you want to know, you need to do until when, right? Okay. So our problem here is to find y at 2.6. Okay. Now here, this is your x naught. This is the place where you put down your x naught. Okay. Likewise, the corresponding n here is 0. All right, not? And of course, over here, this is the place where you put down your y0. Yeah, sorry, not very much on the straight line. So you know, right? This is 0 when n is 0. So every n here, on this row, n is 0. So that's why this x0, this y0. Okay. So this is our x0. Our x0 is 2, right? Yeah. So you will put down your 2 here. And then your y0 here, is also 2, right? Yeah. So you also put a 2 there, right? Okay, as I say, we go and fill up the x first. So this is the place where you put in your x1. All right, now what is your h? Your h in this question is 0.2, right? So if your x naught is 2, what is the next x? Yeah, class, what is the next x? What is this x value in the next row?
2.2.
Yeah, you just add the h, right? Yeah, 2.2, and you can stop at 2.2 or not. Then of course you see here, not yet, you must do until 2.6, right? So that means go to the next one. So your next one will be your next one will be 2. What? Yes, class?
Oh.
Yeah, okay. And then I think the next one will be our 2.6. So we can just stop here. So we know we need to calculate the y until here. Okay. Then after we do this, then we go and fill up the n here. So of course this will be 1, then this will be 2, then this will be 3. It's okay. All right. So all right. So this is how we do it. So let's go and do our Euler method. Okay, let's go and do our Euler method. Okay, it's our Euler method, right? So I identify the function, the x naught, the y naught. So now I need to write down the formula. Okay, so let's go to Euler method to see formula. Okay, there's a formula here, right? So let's go and write down this formula. So this is a formula, right? Okay, now of course you cannot calculate from here. The fxn, go and write out explicitly. And well, you can put in your h as well. Okay, you put in explicitly. So your function xn, yn, meaning that you put your x as xn, put your y as yn, right? So then you get to here. It's okay? Now, this is the formula that you use for your calculation. Is that all right? So in this formula, you see your n here is from 0, 1, 2, 3, right? So of course you start from n equal to 0. So when your n is 0, when your n is 0, then you have a y subscript. Hey, class, when your n is 0, what's your subscript here? Class, when your n is 0, what is your yn plus 1?
Oh, it's a 1, 1. It's 1.
It's y1, right? Yeah. And then of course here your your n is 0, then you go and plus then you get your 0.1, and then all this will be your y0, x0, and so on. Right? Yeah. Is it okay, class? You know how to use this formula? All right, so this is when your n is 0. So that's how you get to here, right? So you see here, actually, they tell you how to get your y1 already. So this is how you get your y1. Okay. All right. So if you go and fill up, this is a formula, right? So if you go and fill up, now this is what I showed you just now, right? This is n, right? Okay. So initially, without any calculation, you can only do until here. Right, you can write down your x. You want to calculate until 2.6, right? Of course, your n, you write them down. And then this is your y0. Okay, that's all. That's all. Yeah, that's all you can do. All right. And then, of course, the next one, this is your next entry, right? So this is the place where you put down your y1. And of course, how you get your y1? This is how you do it. Okay. All right, so you put your y1 here, and then after putting down your y1, and then you come to here, and this is the place where you do your y2. All right, and of course your y2, this will be, that means now your n is like you put 1, right? So that's why your left hand side here is y2, and then your right hand side here will be y1. Y1, X1, and so on. Okay. Then after that, you come here, and that's where you put down your Y3. Okay, just put down your value. You can do your calculation outside here. Is it okay? All right, class. Is that all right? Any questions about this? Yeah, class. Any question about this? So this is actually your answers. All right. And the question is asking for y at 2.6, right? So this is x is 2.6, and this is the corresponding y. This is the numerical solution. So y at 2.6 is actually this value, right? Any questions about this, class?
Prof. So the value that we substitute inside is just substituted inside this yn plus 1, such that we get a value which is 1.94. Am I right?
This is the y3.
Y3, right? So when n equals to 3, that is the value that we're supposed to get. When
This is y3. This is y3, but when you are using this formula to get your y3, actually your n is 2, right?
Yes.
So your y3 is actually a y2. I mean, if you are looking at your formula, y2 plus 0.1, and then bracket, inside the bracket will be a y2 over x2, x2 over y2. Right?
Yes.
Your y2 is above. Your x2 is your 2.4. Okay? That's how we do it.
Okay, understand, Prof.
Okay. So I hope everyone is clear. So this kind of thing, you cannot just read the solution. You need to go and calculate. Because otherwise you read the solution, you also don't know how to get these values, right? Okay. All right, then the next question is, let's come to how many decimal places to put, right? How many decimal places to put? Now your Y column here, you put how many decimal places, class? Class, the Y column, how many decimal places do you put?
8 decimal place.
Yeah, you put 8. Okay. Because this is to reduce your error. Because you see your previous Y is used to calculate your next Y, right? So if you put too few decimal places, then your answers will be like getting more and more inaccurate. All right. Okay. So we put 8 decimal places. Anyone want to ask why I put 6 or not? Well, you can see that here I put 6, right? But I asked you all to put 8, right?
Oh yeah, why is that?
Because you don't have space to write.
Anyone can offer an answer?
There's not enough space for you to write there.
Yeah, yeah, right. Yeah, right. So
But
that's
there's a plenty of space over there on the right.
yeah. But there's some restriction one, no? So actually, why we cannot put 8 decimal places here? Well, that's because we don't have enough space. But y'all will have a lot of space, all right? So y'all put 8 decimal places.
But on the right, you have ton of space over there. But
No. When we type that time, actually don't have so many space. So this later on we paste onto this. Okay, now.
All right.
Okay, then we do the next question. Actually, it's the same question now, just that we use a different method. Okay, so this one is improved Euler method. Okay, formula here. Right, so same problem, so same function fxy, x0, y0, all the same, just that we change the method. So first we need to write down the method, right? Now, this is the method. Okay, that's equation A. Then of course we need to write down our A. And see, this is our A, right? H times fxn yn. So you really put in your H, then your x substitute xn, your y substitute yn. Okay. And then we also need to write down the B. So this one is the B. Fxn plus 1, yn plus 8. So you notice that here, your x, the x, you realize our x is substituted by xn plus 1, right? And then our y is actually substituted by what? Yn plus 8. All right, because this one is yn plus 8. Yeah, everyone can see that or not? So that's how we get to these expressions. And of course, these expressions are important because when you do calculation that time, when you want to calculate A, really follow this one. When you calculate B, you really follow this one. Okay. So now let's go to our tabulation. Tabulation, earlier on I show you already, right? Not this one. Yeah, this is the one. Okay, so you got n, x, n, y, n. But now intermediate values we also tabulate. Okay, so we follow this. Now you see, all the important formula, I bring it to here. So this is my A, this is my B, right? And this is how I calculate the next Y. So I got my n, x, n, y, n, then got A, B. All right. And of course, you see that all these are shaded, right? So this is actually what you obtain without any calculation. That means initially, this is what you have. You got your x, you got your y0, and that is all. Okay, that's all. Okay, now we come to how do we complete this table? Okay, how do we complete this table? So the key thing is that you will complete it row by row. Okay, so that means you finish one row, then you go to another row, then go to another row. Okay, so that's how we do it. So obviously you see that here, this one is 2, right? And then you see that here A and B blank, right? But they are still in row 1, you know. So that means the first thing you do is you need to calculate the A here. All right? Yeah, you need to calculate this A value here. Yeah, you need to calculate this A value here. Now, then you ask, how you calculate the A value here? Then of course, you've got to refer to your A formula. Then you see your A equal to this one, right? Then use this. Yeah, use this to calculate your A. And then when you say, okay, use this, then you see inside that there's a yn, there's a xn, right? Then you want to ask, then what is xn, what is yn? Then you see where is your A here. Now your A is in the first row. Your A is in the first row, right? So in this row, your n is 0. Yeah, your n is 0. So therefore, this one is y0, x0, x0, y0. Is it okay? All right, now. So this is how you get to your A. All right, so similarly, when you want to calculate your B here, right? This is your B. Yep, this is your B. Now, how do you get your B here? Of course, you need to do your B formula. Now, your B here. So you look at your B formula. B formula is like that, right? Okay. Yeah, this is your B formula. Okay. And then over here, you see your yn, xn again, right? You see all the n here, right? And since you are in this row, your n is 0. Okay. You put n is 0 inside. Then of course, inside you also see the A. The A refers to what? Refers to this A, the one that you just calculated. Okay, no? All right, so that's how you get to here. So after you've done this, then of course, what is the next entry to fill? Well, the next entry to fill will be this. Okay, yeah, this is the one. So now you go and fill up your y1 here. This is your y1. Okay, so this is the next entry to fill. And then how to get your y1? Well, y1 is what? Then you follow this formula here. y1 is y0. You can see the subscript decreased by 1, right? So this is 1. That means this is 0. And then plus half A plus B. A plus B over 2. Okay, so this is your y1. Okay. My class cannot come up. A plus B over 2. Okay, yeah, so it is like that. And then of course you want to ask me, the A and the B here, where to get? Well, these are the ones. The one that you just calculated. The one in the row above. Okay, all right, so that's how you get your y1. Then of course, once you finish your y1, then you know that, now you need to calculate your this A and this B, right? Yeah, this now your this A and this B you need to calculate. So once again, refer to the A and B formula. And over here, because now you are in this row already, right? So your n value is 1. So over here inside, the n value is 1. Is it okay? All right, class? Any problem or not? Any questions, class? Well, so this is what you have. All right. Okay, so when you reach here, this is the y value at 2.6, right? Then you can just stop here. Is there a need to calculate this A and this B there? No need. Because this A and this B here is for the next y. It's for the y value at 2.8. But since you don't need that, right? So this one you don't need to calculate. So any questions, class? Yeah, any questions? Is it all right? Okay, so let's come to number of decimal places. So I think you like that. And can I type here? You know what happened. So your y column is 8 decimal places. Okay, 8 decimal places. How about your A column? A column, how many decimal places, class? What do you think?
8.
Yeah, also 8. Okay, because it's involved in the calculation, right? So that's also important. So that means here also 8. Okay, 8 decimal places. So you can see that these 3 rows, they are involved in getting your y, right? So all these 8 decimal places. Okay, any questions here? That's improved Euler method. And of course, once again, you need to really go and calculate. Otherwise, you look at all these numbers, you also don't know how they come about, right? Yeah. So this one is really for you to practice. Okay, you cannot just read the solution, because you read the solution, it's not meaningful. Okay. All right. Let's now go to Runge-Kutta method. So Runge-Kutta, now that's our Runge-Kutta, right? Wow, of course, it's longer for us to write down, right? So first we write down the how we get to the next y. All right, then you see you got all this ABCD, right? So the ABCD, you have to write following this, and we need to write explicitly. All right, so you see this is our A. This A actually is the same A as the improved Euler method. The formula is the same. All right. The B is different. So this is B, right? HF. I see. Now your XN, your XN, I mean your X, you got to substitute this. Now your X is XN plus half H. And then your Y, your Y is YN plus half A. All right, so you see, become like this. Then of course your C and D is also done similarly. Now, of course, the expression look complicated, but we'll follow them to calculate our ABCD. All right. Okay. Let's go to our table. Now, that's our Runge-Kutta, right? I see. Wow, so many columns. So now, before we start, can you tell me which are the columns need 8 decimal places? Which are the columns that you need to put 8 decimal places? Yeah, class, anyone?
It's kind of every single column except the first and second one.
Yeah. So in fact, your YN, A, B, C, D, all 8 decimal places. So that means only your N, your XN, no need. Okay. Yeah. So usually when we do this, we can do it landscape. You all know landscape, right? Yeah, so we can do it landscape. Okay, so this is what we have. And if you look at our table here, initially, this is what you have. Right, so you can only have the Y0 here. The rest all unknown. So wait for us to calculate. All right, so then you see, the first thing is, you see here, the first row, your A, B, C, D blank, right? Okay, go and calculate them first. After you get your A, B, C, D, then after that, where's the next column? Where's the next entry? Then your next entry will be your Y1. That's your Y1. Okay. Then after that, your A, B, C, D again. Okay. Then you come to here. Then become like this. Then your A, B, C, D again. All right. And then finally, you get here. All right. Then what about this one? Well, this one you don't need 8, so no need to calculate. All right. So this is your Y at 2.6. That's the number here. Okay now. So class, any question? Class, any question or not? Has anyone done this problem? Anyone done this problem already? Yeah, I think you need to do. Yeah. Okay, so this is considered as question 1, considered as very, very easy. Okay, so now we go to more complicated stuff. Okay, let's look at the summary first. Right. So far we only solve one equation. All right. I mean, so far our problem is just to solve one equation, right? You see, just consider one differential equation only, right? Only one initial value problem, right? Now you see your differential equation, how many are there? And only one. So very simple, right? So now we have more complicated things. So now we are looking at a system of first order ordinary differential equation. Now the word system, system meaning what? System meaning more than one. Okay, if one, that's not system. So system means more than one. Okay, so that means we will solve more than one differential equations simultaneously. All right, so I think the key word is simultaneously. They are connected to each other. Right, so this is actually our system. This is our first order system. So if you look at it now, then you see it also look like before, right? Also got y prime function xy, and then yx0 is y0, right? But there's something else. And you see that on top of them, you know, other than x, other than your x0, the other things, they all have a curly hair on top, right? You all see curly hair? Yeah, maybe some of you also got curly hair. I am not in class. I'm not in seeing you in class, right? Otherwise, I'll see that some of you may have curly hair, right? So this curly hair on top, actually we call it, got a name, all right? We actually call it tilde. Okay, yeah, you know this sign, you know, the one that looks like curly hair, right? It's actually called tilde. Yep. Okay, now this tilde thing, what does it mean? Now the tilde thing actually means that inside, although you see it only got like one item, right? But actually inside got more than one item. All right, so this is actually the meaning of tilde. So you see here, U tilde, right? U got curly hair. So meaning what? Oh, inside actually got a few things. Got U1, U2, and so on. All right, that's the meaning. So you imagine, wow, all these all got curly hair, you know? So that means every one of these, those with curly hair, means inside got so many things inside. Okay. Okay, so let's go and look at it more closely. Well, this one is how we handle the curly hair. It's like calculus. So for example, this is our U tilde, right? This is our V tilde. Now, how do you add? How to add? Very intuitive. How do you add? You just add component wise, right? You just add component wise. And then how do you equate? If you say U tilde equal to V tilde, what do you mean? Well, what you mean is that first component equal first component, second equal to second, and last one equal to the last one. All right, so it just means this. So it's also very intuitive, right? And how about if you take a constant times U tilde? Well, then you just go and multiply every component by that constant. Is it okay? All right, so all this is very intuitive, and you can see that it's actually from our lecture notes, right? Okay, now this one also from our lecture notes. So now I want to take a look at this, the y prime tilde and the f tilde xy tilde. All right, because our first order system says that this one equal to this one. So we want to see what it is. So y prime tilde means y1 prime, y2 prime, yn prime. All right. And how about our this one? F tilde, xy tilde. Now here, your xy tilde, these are your arguments. All right, they are the arguments of f tilde. Okay, so this is what it is. So this f tilde means got f1, f2 until fn. All right, then the xy tilde, these are the arguments. Now arguments means every component they will have the same argument. Okay, so you see f1 xy tilde, f2 xy tilde, and so on. All right, then we can open up further, and you see inside still got the y tilde, right? So for example, your f1 xy tilde, your y tilde, you go and write out all is y1, y2 until yn. Okay, then of course you also know what is f2 xy tilde and so on. All right, so now when you say that 1 equal 2, all right, we have 1 equal 2, right? item number 1 equal to item number 2, right? So first one equate to the second one. So remember how we equate? How we equate is first component equal to first component, right? Second component equal to second component, and so on, right? Yeah. So if we just write down the first one, first component equal to first component, then this is what we have. Y1 prime equal to F1 X. And then this one, if you write it out, then it's Y1, Y2 until Yn. Is it okay? All right. Yeah. Everyone clear or not? So that's how you get your first equation. And of course, when you have second component equal to second component, then you get another equation, right? Then you also can imagine what it is, right? Until the last one, right? Yeah. So that is how, you know, our this first order system, when you write out all, and you write out, you actually get from here until here. You get Y1 prime is this, Y2 prime is this, Yn prime is this. All right, so there are actually m first order differential equations here. Each of them is first order differential equation, right? So that's how you get to here. All right. Then now we also want to see the initial condition. Right? See, this is actually an initial condition. Yeah. So how to get that? Okay, we got this notation is y tilde x naught. So it is y1 x naught, y2 x naught, and so on, right? Yeah. And then we get our y naught tilde here. Right. So we get our y naught tilde here. Now this y naught tilde it's just a notation, all right? So what it means is this. Well, here already got a naught here, right? The subscript, right? Then you still want to have another subscript. So therefore, we end up with 2 subscripts. So we got the y1 0, y2 0, ym 0. Okay, so now 3 equal to 4. All right. Yeah, that's what we have. 3 equal to 4. 3 equal to 4, right? Item 3 equal to item 4, right? And you know how we equate, right? First component equal first component. Okay, yeah. And that's how you get to this. Right, so y1 x0 is equal to y1 0. And of course, your second component, this one here equal to this one. So that will give you another one, right? Then of course, the last one equal to the last one. Okay, so these are actually the initial conditions. And it will give us all this. Okay, so that's how all these come about. So they actually come from here. So is it okay? All right, so 13 is a short form. It's a
Professor.
Yeah.
So in the step 14, why do we need to change from y1 in x0 to y1 comma 0? Like what's the purpose of changing that?
This y1 0 actually is a constant. Although here we write it like that, right? But when we are doing the problem that time, this is actually a known constant.
I get it. But why do we change from y1 x0 to y1 comma 0?
So y1 comma 0 is the constant that we have. y1 x0 means the value of y1 at x0.
Okay.
So here we are not just having one y. You know, previously we only have x and y, right? But here,
Yes.
what we are having is that we are having x. We are having x. X is still our independent variable. But then we got the y1. So y1 actually depends on x. All right. Previously you only have y, but now you have y1. And then we also have a y2. So y2 is like another function, also depends on x, and so on. And of course, the last one that we have here is called ym, right? So ym is also a function depending on x. Yeah.
All right.
Yeah. So you see the problem is more complicated, right?
Yeah, definitely.
Of course, you say, wow, so complicated, right? How do we handle? So usually in our notes, in our examples, m is 2, because if too high, then we cannot handle. I mean, we are human, you see. So if too high, then it will become very complicated. So that's why in our notes, in our tutorial, so far we only handle 2 equations. Yeah, it's okay. But in general,
Yeah.
we can
But
handle.
what does m represent?
M is an integer.
Yeah, but what does it represent?
Oh, it represents the number of dependent variable that you have. All
So-
these y1, y2 until yn, because they depend on x, right? So we
Okay.
call them dependent variable.
So
Okay,
how
functions of x.
how do you find this m?
What?
How do we get this m?
Oh, this one is from the question.
Oh, it's just given?
Yeah. So it's like solving simultaneous equations. So maybe the question asks you to solve 2 simultaneous equations. Maybe the question asks you to solve 3 simultaneous equations.
Oh,
So
okay.
you will know. Is it okay?
Yeah, sure.
So now we are going to talk about how to solve this kind of this kind of system. So actually the good thing here is that we no need a new formula. The methods for single first order equations, just now our 3 methods, can be extended to the system of equations by doing this. By doing what I boxed in here. Okay, so in our previous formula, what we do is that almost everything, you can see the y, the f, the a, b, c, d, all you change them to tilde, right? There are 2 things no tilde. X, independent variable, x is still x. Your step size h is still h. Yeah, whereas the rest all become got tilde, right? So that's the trick. So yeah. So before maybe we go to our Euler method for systems. Earlier on we got Euler method, right? So now we have Euler method for systems. Okay. This is page 18, right? So if I go to page maybe 3. Right, page 4. There's our Euler method. See this Euler method, right? So what we do here is you just go and add tilde. You put a tilde here, tilde here. Your f also got tilde, right? X don't have, then y also got tilde. Then becomes Euler method for system. So that is our page 18 here, right? Yeah, so therefore we get all this. Is it okay? So Euler method for system. Okay, so just like that. Then of course you say, hey, just like that. Oh, very easy. No, not so easy. Because I mean, you go and put curly hair is very easy. But exactly what it means, right? Exactly what it means. So I need to go and explain these 2 notation. So actually it's in the previous page. And you can see that it's actually from our lecture notes, right? Yeah. So yn tilde means y1n, y2n, and so on. All right. And then yn plus 1 tilde is y1n plus 1, y2n plus 1, etc. All right. So then you see, got 2 subscripts. There are 2 subscripts here. So notation of these 2 subscripts. Okay. Of course, the first one is the red one, right? The second one is the blue one, right? What do they mean? They actually got meaning. All right, actually got meaning. The first subscript tells us which dependent variable. All right, which dependent variable, meaning is it y1? Is it y2? Okay, which one? All right, you're talking about y1 or y2 or what? Okay, so that's the meaning. The first one, the first subscript will tell us that. And then the second subscript will tell us at which grid point. Grid point means at which x. Okay, at which x. So let's take an example, y1n. So of course we are talking about y1, right? Yeah, y1 at which x there? At xn. Okay, so y1n means approximate value of y1 at xn. Is okay? That's the meaning. Okay, another example, y2n plus 1. So here we are talking about y2, right? Then n plus 1 meaning what? Oh, y2 at the point xn plus 1, approximately. Is it okay? So this y1n, y2n plus 1, all these they are numerical solutions. So over here, the right-hand side, that's the exact solution. Okay, not? So now we know the meaning already, right? Okay, so, well, I put my yn tilde and my yn plus 1 tilde here. Okay, so I got my Euler method for system. Okay, so as I say, we need to interpret this, right? So what's the meaning? So the meaning of this is you got your yn plus 1 tilde, right? Yeah, so that means all these things, and then equal to yn tilde. Well, there's a yn tilde, right? Let's equate them component-wise, because you see this equal sign here, right? So that means the component of the left side equal to the corresponding component of the right side. So this is what we have. The first component here, you've got your y1n plus 1, right? See? You got your y1n plus 1. Yeah, then here, first one. Then your yn tilde, this is your first component. So that's why you get your y1n. Then plus your h. Now your f tilde. Well, obviously the first component is f1. Okay, then your xn, yn tilde, what about them? Well, these are the arguments. Now, arguments, you just write out everything. Now, that's the argument. Is it okay? Yeah, so it's just like this. All right, so you get your first equation already. All right, and then obviously you can get your next equation, right? If you can do the first one, then obviously you can do your second one, right? Yeah, and so on. Is it okay? All right, so this is called Euler method for systems. All right, now. Okay, so then we go to the next one. How about improve Euler method for system? And same thing, we just go and add tilde, right? I see your A, B also got tilde. Hey, your A tilde, B tilde, I see everything got tilde. What are the things no tilde? Your H, your X, and of course your constant. Your half is also a constant, right? So of course also no tilde, right? So how do we interpret this? Well, the first one is easy, right? You see your yn tilde, your yn plus 1 tilde, the meaning is on top, right? So equate the I component. Well, now we more expert already, straight away go to more general I component. So obviously your I component, suppose it's a first component, it will be this and this, right? Yeah. You see your y1n plus 1 equal to y1n, and then half. And then how do you add these two there? And what is the first component there? It will be a1 plus b1, right? Yeah, so that's how you get to here. Okay. And after that, you want to write your a. This is your a tilde. So that means your I component is your ai, right? Yeah. And your f tilde there, then fi. Then your arguments there. What about your arguments? Well, arguments, write out everything. All right. Argument is everything. Okay. Then how about your b? Your b will be like this. There's your bi, your I component, and then your fi. Then these are your arguments, right? So this one is this. And then you see that, wow, this one add. Wow, how to add? Adding component wise. Okay, so that's why you get y1n plus a1, y2n plus a2, and so on. Is it okay? All right, so this one actually is this. Okay, now, yeah. So this improved Euler method for system. All right, and then, wow, the next one, of course, you know what is the next one, right? Runge-Kutta. Wow, that's Runge-Kutta with all the curly hair there. Well, it doesn't look too bad, right? Doesn't look too bad. But if you want to write it out all, then will be more complicated lah. The first one still okay. The first one is just like that, right? So it will be just AI, BI, CI, DI. Yeah, first one is still okay. Right, so this is what we have. Yeah, it's the first one. And then how about your A? Well, this one actually same as the improved Euler method, right? So the A we can also handle, same as the improved Euler method. So this is the A, not too bad. Then the B, well, this one obviously is BI. Then this one, this one will be FI. Then this will be the component, right? This will be the component. So I mean argument. So argument, write out all. Okay. Yeah. Well, I see that the first one is what now? xn plus half h all. Yeah, the first one is like this. Okay, let me go and see this one. Is it like that? Okay, so that's what we have. Yeah, so you can see the first one is your xn plus half h, right? Yeah. And then how about subsequent one? Oh, subsequent one is yn tilde plus half a tilde. Now this one, you need to add them component wise. Okay. And if you are adding component wise, that means you will get y1n plus half a1, y2n plus half a2, etc. Cannot. So based on the same principle, that's how you write down your CI and your DI. Okay. Now, of course, all this looks like complicated, right? But when we do the problem that time, actually less complicated, because in our problem, as I told you, most cases we just do m equal to 2, right? Yeah. So therefore, you don't have so many things. You only stop at y2n only. Okay, so it's much less complicated. Okay, not. All right. Yeah. So maybe I show you our tables. Yeah. This is my Euler method, right? How about the one for system? So of course here, mine is a special case. I only do m equal to 2. All right, so that's why I only have a y1, y2. I only got y1, y2. Okay, yeah, I don't have so many y. I only got y1, y2. Okay, these are my dependent variables. Okay, so therefore, previously it's only one y, right? Yeah, but now there are two y's, so I put y1n, y2n. Okay. Then this is the improved Euler method, and then I think you can imagine, right? Now your y becomes what? Oh, got y1n, y2n, right? Then what about your AB? Oh, they also have. You see, y1n, y2n. Then you got A1, A2, B1, B2. Right? And you got Runge-Kutta method. Well, I think you can imagine very well, huh? Your y got y1, y2. Then your A, B, C, D, well, each of them also got A1, A2, B1, B2, and so on. Right? So you can imagine, this is our table. Right? Everybody looking at this table, right? How many tables are here, class? 8 class. You know, this page that I show you, how many tables are here?
One table?
Yeah, there's only one table. All right, just that because the page is not long enough, so the table is like got 2 layers. So actually it is you carry on from here. You actually carry on from here. Actually carry on from here. You know, this is A1, A2, then actually B1, B2, C1, C2, D1, D2. Actually, this one follows behind. All right, but no space, so we put it here. Okay, all right, so this is one table. Okay, so now can we go to the next question? Well, not yet. Now, why are we learning all this, how to solve a system of first order equations, right? Do we really go and solve first order system? Not exactly. We actually like use it as an application. You know, we apply this to go and solve. Wow, this one more complicated. Wow, even more complicated. We go and solve higher order ordinary differential equation. Okay, this time is not a system, but rather it is higher order. What's the meaning of higher order? That means the derivative, the order of derivative is more than 1. Previously, you only know y prime equal to function xy, right? That's first order. So now higher order. So you see here, m derivative of y. Your m here is greater or equal to 2. Is it okay? That means from second order onwards, it's called higher order. Okay, so m derivative of y equal to function of all these. So the function can involve x, y, y prime until the m-1 derivative. All right. And we also have m initial conditions, y at x naught, y prime at x naught, and so on. Okay, so this is our ultimate aim. Maybe I write down, this is our ultimate aim. Okay, so our ultimate aim is to solve this kind of equation. Okay, by using this how we solve system of first order equations. Okay, right. So then you wonder how we do that, right? What we do here is we actually go and rewrite this m order initial value problem. Go and rewrite it. Yeah. Okay, rewrite it as what? As a system of m first order differential equations. Then after you go and rewrite all, after you go and rewrite into a system, right? Then what do? Then you can go and apply your method for solving system to go and solve it. Is it okay? Yeah, so this is how we do. Okay, then now we come to the question of how do we rewrite? Okay, how to rewrite? So actually this is the standard method. We set, okay, what do we set? We go and set new dependent variables. Okay, so we are setting new dependent variables. Setting new dependent variables. Okay, we are setting new dependent variables called y1, y2, and so on. Okay, you see previously it's only called y, right? So now we are setting new dependent variables called y1, y2, and so on. Okay, how do we set? Now this is a standard way of setting. We let y1 be y, y2 be y prime, y3 be y double prime, and so on until you got ym. Now, of course, this m is the same m here. Okay, yeah. So that's the m-1 derivative of y. Okay, so if you do this, if you do this setting, all right, then if you do this setting, then our this m order differential equation, is 30, equation 30, it will become a system of m first order equations. So you actually become the system here. Okay. Now I won't be explaining this, but I will, in fact, I will show you how we get all this from our tutorial problems. All right. So the trick here is that if you do all this, you set y1 to be y, y2 to be y prime, and so on, then our m order initial value problem will become a system of m first order equations. And then we can just apply our, the 3 methods for system to go and solve it. Yep. Okay, understand? Yeah. So this is how we are going to do. Okay, well, I talked a lot. So now maybe we go and do some problem. Okay, so let's go and do this one here. Now consider this initial value problem, right? So you see y double prime. Everyone can see y double prime or not? So this is a second order equation, right? So this is a second order equation. Yeah, so this is a second order equation, right? Second order differential equation. So that means higher order. So what do we want to do? We want to use Euler method, okay, with this step size to approximate this one and this one. Okay, all right. Now, everybody clear, huh? So higher order initial value problem. So what is the first step that we do? So the first step that we are going to do is, well, it's stated here, right? We are going to set y1 to be y, y2 to be y prime, until yn to be the n-1 derivative of y, right? Then you become a system, right? Now over here, second order meaning what now? Meaning that our m here is 2. Second order, m order. So m is 2 here. Is it okay? All right. So if m is 2, so that means our last one is what now? You only do until ym, right? So that means until y2. Is it okay? So basically it's the first two. So we are going to just set y1 to be y, y2 to be y prime. Is everybody okay here? We'll set y1 to be y, y2 to be y.
Professor.
Yes.
So m is the order of the equation, right?
Yeah. Yes. M is there you see m order initial variable problem, right? So
Okay.
m is the order of the equation.
So why do we stop short of the last order? Like I'm talking about m is 2, right? Why not like go to until y3?
Because there's no need. There's no need.
All right.
Only need until ym.
Okay.
Okay. So we go and do this. Let me see my solution here. Okay, so that's why you see here, this is my problem, right? So I say let y1 be y, y2 be y prime. Okay, so here, now let's do this together. Let's do this together, okay, can I change the color? Okay, so maybe we change to blue. All right, yeah. So let's see here. Let's see here. I don't know whether I type here easier or type here easier. Maybe I type here. Is it okay? Yeah, then you can still see here. So from our first equation here, this one is our first equation, right? Yeah, y1 equal to y, right? So what I'm going to do here is that I'm going to prime both sides. I'm going to differentiate both sides. So that means y prime subscript 1 equal to y prime. Is it okay? All right. So from my first equation, let y1 be y, right? I go and prime both sides. Then get the y1 prime equal to y prime. Everybody okay? Okay, right? Yeah. And then I'm not going to write y prime anymore because now I already changed the dependent variable. Everything is just y1, y2, right? So my y prime, I'm going to write it as y2. Okay, because, well, that's what it is, right? You see, your y prime is y2, right? Yeah, so this is what I get. So I actually get my first equation already. I get y1 prime equal to y2. Is that okay? All right, I actually get y1 prime equal to y2. So this is my first equation. All right, I get y1 prime equal to y2. And you know how I did it, right? Okay, so I will call this function 1. Yeah, so this will be my function 1. And the arguments are x, y1, y2. Okay, now I'm going to get my second equation. Now my second equation will come from this second equation here. And what I'm going to do is, again, I want to differentiate both sides. All right, so let me go and differentiate both sides here. Okay, class, on your left side, I hope you can see. So I will get y prime subscript 2. And then the other one there will be get y double prime. All right, because y prime, you differentiate again, becomes double prime, right? Now, what is y double prime? Because I don't want to have y anymore. Okay, so what is y double prime? Y double prime, is it called y3? Y double prime called y3 or not? How to get y double prime? Yeah, class, how do you get y double prime? Anyone? You know how to get y double prime? Is it y3? No, it's not y3. Then how to get y double prime? It's actually on this page. Can you see y double prime? Can you see your y double prime here? Yeah, everyone can see my my cursor. See your y double prime here, right? Yeah. So you actually get your y double prime from this equation. Right? Yeah. So from this equation, how to get y double prime? So that means these two terms you shift to the other side. So you get minus 2 y prime square. Y prime square. Okay. And then minus 10y. Right? So that is what you have. Yeah. And of course, here, once again, we don't want to have y prime and y, right? So I will rewrite them. The y prime is now known as y2, right? Yeah, y2 square. And the y is now known as y1. Okay, so that's what I have. So eventually, this is what I have, right? So this is what I've written down. Yeah, so this is what I have. So y2 prime is minus 2 y2 square minus 10 y1. Okay, and I shall call this function 2. Okay, all right, so you see, until now, I have already written 2 first order equations. This is second order, right? 1 second order equation. Now it has become 2 first order equations. All right, not the end yet. These initial conditions, you also must rewrite. Okay, your initial conditions, your y is now known as y1, so that's why it's y10. Your y prime is now known as y2, so it's y20. All right, and this is our notation. Just now you all asked me about the y10, y20, right? This is actually our notation. So this means initial value of y1, okay? This means initial value of y2. Right, it's just a
Professor.
Yeah.
Why for the y2 prime? Why don't we write it as y3? Why do we write the shift equation over there?
Because we don't have y3, we only have y1, y2. See?
Okay, and for this, why don't we write the shift equation for the y2 as well?
Well, I did use both equations, right? The first equation I differentiate, it gives the first one. The second equation I differentiate, it gives me the second one.
Also, babe, so we will write our equation over there. But how do you find the y1 prime again?
You mean the first one?
Yeah, the first one. How do you find that?
I differentiate this. You will look at this side here. Y1 prime equal to y prime, right?
Yes.
Y prime is just y2.
Also, just that.
Yeah, y prime is just y2, right?
Oh, all right.
Okay. All right. So when you reach here, well, you complete that. Now your second order initial value problem now become a system of 2 first order equations. Is it okay? All right. Okay. So now, what method do we use? Oh, Euler method. So actually, this step here is a universal. That means regardless of what method you are going to do next, whether you want to use Euler, improve Euler, or maybe Ruger-Kutta, all right, this one you need to rewrite first. All right, so after rewriting, this is your function 1, this is your function 2, right? Now, then you go and see what method they want. Okay, I want Euler method. Okay, let's write down Euler method. Okay, here I also put down my function 1, function 2, because I need this when I write this. Okay, yeah. Euler method for system is like this. And of course, you cannot calculate from here, okay, because you don't know what it is, right? So you got to write it out. Okay, so when I say write it out, that means now you got your y1, y2, right? So you need to write out what is your y1, what is your y2 from this formula. Okay, right. So let me see my first formula here. Oh, my first formula is for y1. Okay, you do component wise. All right, this is my y1 n plus 1. This is my y1 n, your h, your f1, and your arguments. These are the arguments. Arguments write out in full. Okay. And then don't stop here. Write out further. What is your f1 this? What is the meaning of f1 this? All right. Well, that's the place where you need to know what is your function 1. Your function 1 is like that. This is your function 1, right? f1 x y1 y2 is y2. Right? It's actually from here, right? Yeah, this one is y2, right? Okay, so equal to y2 meaning what? Meaning that equal to the last argument. Okay, yeah. So therefore here your f1 this, right? The last one is of course your y2n. So that's why you get your y2n here. Is it okay? All right, now. Yeah, this one usually quite easy. Then we go to the next one. How to write down your y2n plus 1? Okay, this one is your y2n plus 1. This one is your y2n. Then you got your hf2, and of course your arguments are here. Your arguments are here, right? Yep, these are arguments. Okay, now to go to the next step, you need to know your function 2. Now, your function 2 is here. Okay, function 2. Function 2, x, y1, y2, what is it? It's minus 2 y2 square minus 10 y1. Minus 2 y2 square. Y2 is what? Y2, let me change the color. Y2 is actually the last argument, right? So that means your last argument square. And then minus 10 y1. What's the meaning of y1 now? Y1 here actually is which argument? Actually is your middle one, right? It's actually the middle one. Y'all see? Okay, so this is the rule. This is the rule. So what we do is that we take the minus 2, the last one square. Now look here, the last one here is this, right? So that's why you get the last one square. Okay, and then minus 10 times the middle one. The middle one here is y1n. So that's why you get your 10 times y1n here. Okay, all right. So that's how we get.
Professor. So basically, we actually replace the old variable with the new variable that they match, right?
Yeah. So that means we don't deal with y now. We deal with y1, y2.
So basically, I have like y1. We just change to y1n and y2 to y2n, like something like that.
Oh,
all right.
So actually, our y1 now is the previous y.
Yep.
And our y2 is the previous y prime.
Oh yeah. Yes.
Yeah. Yeah. It's like that.
Okay.
Okay. All right. So these two, now we have written down these two, right? So these two will be very important because these two will tell us how to do the calculation. This is, you will look at this formula when you want to calculate y1. When you want to calculate y2, you will be using this formula. It's okay. All right, so these two formula I'm going to transfer to the next page. There's your y1 formula, your y2 formula. Okay. Then finally, we are here. We want to do our tabulation, right? And this is a table that I showed you earlier. This is for Euler method for system. So I got my n, xn, y1n, y2n. Okay. Yeah, I think it is here. It's the one, right? So maybe we do here. Let's do here, I wonder whether I'm able to type. Okay, so n is 0. Now this is the place where I need to put my x0. This is my x0 place, right? Can you tell me in this problem, what is my initial x? Just by looking at the question on your left.
0.
Yeah, it's 0. You all know how to see it? Do you know how to see or not? To get the initial x, you look at this. You look at this. Y0, y prime 0. All right, so that's the initial x here. So the initial x is 0. All right, and then of course, my y1 0, this is your initial y1. Your y1 is y, right? So this will be your 0. That is this 0 here. Okay. And the next one is my y2 0, the initial y2. My y2 is y prime, right? So this is 1. Okay. So this is actually this one is my yn. Okay, that's the previous yn. And this one is actually my y prime n, the previous y prime. Is that right? So this is how you get it. Okay. Then of course, we say that we want to fill up the x first, right? So your next x, your h is 0.1, right? So what is your next x then? What is your next x?
Let's just go by 0.2. I mean 0.1, yes. 0.1.
Yeah, 0.1. Add the h, and then add another h. Then become here. Is it okay? And of course, then you can fill up your n here and fill up your n here.
Professor, why exactly we don't need the y3? Like I don't get it. Why don't we need the third y?
Because you don't need.
Yeah, but why is that?
Because your y3 will be your y double prime, right? And then when you go and differentiate both sides, they are going to get y triple prime. And how are you going to write down your y triple prime?
I have no idea.
Yeah, so that's why we don't do that. Okay. Yeah, because it cannot work. So that's how we get our n, we get our xn, and of course here, this is our, well, initially, this is what you have only. Is okay? And then you will use this formula to go and calculate the 4 numbers here. All right. So this number, for example, this is called y subscript 1, 1. Right? The n here is 1 because you see your n here, your same row, right? So your n here is 1. Yeah. And your next one is called y subscript 1, n, and your n here is 2. Is it okay? Yeah. And then of course here, this is my y subscript 2, what class? Class, do you know what is the n here?
2.1.
Yeah. Okay. And this is my 2, 2. Okay, because my n here is 2. Is that all right? Okay, then how to calculate all this? Of course, you got to fill up row by row. So you do your y11 first. Y11, how to get y11? Use this formula. Okay, so if you want to have y11, then this will be y10. Yeah, make sense? If this is y11, then now you see the subscript decreased by 1, right? So this is y10. So likewise, this will be y20. All right, that's how you do it. So similarly, if you want to get y21, then you look at your y2 formula, y21, right? So this is y20. Then of course this y20, y10. Okay, then you just go and substitute the values, right? And that's how you do this. Okay, so you do this, then you get to here. All right. So as I mentioned, your y1 is your y, right? So this is actually your y. So when you want to get your y value, you see they want to get y at 0.2, right? So y at 0.2, this is actually the y. Y at 0.2, this is your x, right? Y at 0.2 is this, and this is actually the y prime at 0.2. Okay, so that's why you get these values. Is that okay, class? Any questions? Right. Okay, so this one I go slower, right? Now I go to the next question. So this tutorial is longer and I want to complete this tonight. Huh? Okay, so the next one is we consider this initial value problem. Well, once again, you can see that. Can you tell me what is the order of this equation? What is the order of this equation? Question 3. Class. This one is y double prime, right? Yeah, that's the highest order of derivative, right? So this is a second order, right? So what is your m here, eh?
2.
Yeah, so your m here is 2. Is it okay? All right. So, well, we have an initial condition here. So this time we want to use what? We want to use improved Euler method. Okay, improved Euler method. Okay, with this step size to find approximate values of this and this. Okay, right. Yeah. So can someone tell me what is the initial x here? What is the initial x here? Just now our initial x is 0, right? How about in this question, what is the initial x there? What is the initial x here, class? I'm trying to put in my
Two.
Okay. So our initial x here is 2. You all know how to see or not? See from here, y2, y prime 2. So our initial x value is 2. All right, well, you want to do until 2.3, your h is 0.1, right? You know what to do. So next one, 2.1, 2.2, 2.3. Is it okay? So it is like that. So your n here will be 0, 1, 2, 3. Okay, now. All right, all. So, okay, so let's do the same thing. M is still 2, right? Yeah, so I still have y1 is y, y2 is y prime, so you let it be so. And I'm going to rewrite this into 2 first order equations. All right. Now, the first equation, when you differentiate, it will just like what I did before. Okay, it won't change. It will just give you this. All right, just like before. Just like before. You know, when you differentiate, you will get y1 prime equal to y2. Okay, so there's this one here. But the second one you differentiate there will be different now. Yeah, the second one when you differentiate, it will be different. Your second one differentiate, you will get the y2 prime equal to y prime. Okay, double prime. So what is y double prime, class? How to get y double prime from this question? Equal to what? How to get y double prime? Can you all see? How to get y double prime?
Just move to x, y prime x plus.
From here. Okay, so you'll get it from here, from our equation, our first equation here. So if you do that your y double prime will be x squared. And then, okay, you got another 2 terms, right? Xy prime, yeah. And then minus y. It's okay? And then, of course, you don't want to have y and y prime. Now they should be called by the new name. Your y prime is now called y2. Yeah. And your y is called y1. Right? y1. Yeah. All right. So it's like that. So this is actually our second equation. And see, x squared plus xy2 minus y1. Yeah, everyone can see, right? Then of course, your initial condition also go and rewrite. So you have your y is now y1. So y12 is this. Your y prime is now called y2. Okay, right. And then of course, you know, this is our notation, right? So we call this y10, call this y20. Okay, not. Then just now we also know this is a function 1, function 2, right? Yeah. So my function 1 always the same. It's always y2. But your function 2 will change because it depends on your equation. Okay, all right. So far, okay, yeah. So now, okay, improve Euler method. Now we need to write down improve Euler method. So I got my F1, F2 here. I'm going to write down my improve Euler method. Now, this is my improve Euler method. Of course, cannot just calculate from here, right? So you got to write everything out explicitly. So meaning you need to write out your y1, your y2, your a1, a2, your b1, b2. Okay, so let me write out the y1 and the y2 first. So this is my y1 n plus 1. It's actually from here. Okay, y1 n plus 1, then you got your y1 n, and then half a1 plus b1. Okay, likewise, this is your y2 n plus 1. Okay, so this first formula, when you want to calculate your y1, you refer to this. And then this one, when you want to calculate your y2, you will use this. All right, then of course you see inside got a1, b1, a2, b2, right? So what are they? Then of course you must also write down. Okay, so let's go and write a1. A1, how to get a1? Let me change the color. Okay, so maybe we change to this color. Okay, so first we get the a1. So a1 is just hf1. All right, so of course this just follows from here. So you get your a hf1, then this is your xn, y1, n, y2n, right? Yep. And what is your function 1? The function 1 is just y2, the last argument. So it's just this one. You see? Okay, let me also write down the b1 because this also deals with function 1. So to get b1, then of course I need to look at this one here, right? Yeah, so b1 is hf1. Yeah, so let me show you this. So you see I got f1, then got the xn plus 1, and this one add together, right? So y1n plus a1, y2n plus a2. Okay, now f1 this equal to 1. So remember your f1 is just y2, right? Is the last argument here. Okay, so where's our last argument here? Is the 1. Right, so that's why it's equal to h times this. Is it okay? All right, so that's how you get your a1 and b1. And let's do the a2, b2. So here my a2, right? So my a2 is actually hf2, this thing. Okay, you need to look at the f2. F2 is x squared plus xy2. Y2 is this one here. Okay, and then minus y1. Y1 is actually which one? Y1 is actually the middle one, right? Yeah. So you see, this is how it works. Yeah. So if you follow this, then you just get your xn squared, then plus your xn, your y2n, then minus your y1n. Okay, I hope it's okay to you. Now let's look at B2. So B2 will really test whether you really understand or not. So B2 is like that, right? Okay, follow your F2, follow this rule. So how will that be? Okay, the first thing is x squared. X squared. Right? So this, what happened? How come the whole thing become like that? Okay, so see, so we got our x here, and then you go and do x squared, right? So over here, what we are having is that we are having xn plus 1, right? So you will have xn plus 1 squared, that's the first term, and then plus xy2, the first one times last one. First one here, xn plus 1, Okay, and the last one here is y2n plus a2. So that's how you get here. All right, so in fact, these three colors here, if I'm able to replicate, I'm able to replicate the color here. So this is the orange, and then we'll have a green. So the middle one is the green one, and the last one is the pink one. Okay. So see, these are the three, right? Yeah. So now you've got your xn plus 1 square, then your first one times the last one, okay, and then minus the middle one. Yeah. So I hope everybody knows how to do this. Okay, now. Okay, so finally we come to the table. This is a table, right? So just now we already write down the x, right? We also write down this initial y1, initial y2, and the rest are unknown. Okay, see a1, a2, b1, b2 unknown, right? Okay, how we do this? We'll compute in this manner. Do a1 first, then a2, then b1, then b2. Right? When you are doing all this, you will refer to all this formula here. You know, you'll refer to your a2 formula, your b2, and earlier on you got your a1, you got your b1, right? Now in all this formula, you see that there's an n. Yeah, see that there's an n, isn't it? Yeah, n is here. Yeah. When you are in the first row, okay, when you're calculating your a1, a2, b1, b2, your n is 0. All right. So that's how you do it. Yeah. So after this, then of course you need to calculate your this one here. This is your what? Y. This is your y subscript 1, 1. Okay. Yeah. And then you come to here. It's your y subscript 2, 1. Okay. Yeah. So this is your 1, 1. This is your 2, 1, right? How to calculate? Here y1, here y2. Okay, y1 refer to your y1 formula. Y2 refer to your y2 formula. That's how you do that. Okay, so you get this done. Then after that, you want to complete the row, right? Then you go and calculate this row. So actually this one you also done it already. Okay, right. Then after that, you do this one. Then after that, you do this one. Okay, then finally you are here and you get this. And this one here, this one no need to calculate because you are not going to calculate the one at 2.4, right? Okay, now. So these two values here, this is actually the y value at 2.3. This is the y prime value at 2.3. So that's how you get to this. Okay. Any questions, class? Now, of course, all these, if you just listen to me, you won't know how it works. This one is you really need to go and do it yourself. Okay. Well, this one you just have to do it. All right. There's no way that by looking at this, then you can see that how it is done. All right. You really need to go and use all this formula. Go and substitute yourself. Make sure that you substitute, you know how to substitute, you know which value to substitute to get all these numbers. All right. But I wonder whether any one of you has completed this problem here. Anyone? If there is, let me know. Well, looks like no one, is it? Okay, so make sure that you really go and do it, okay? You don't want to wait until exam and then that's the first time you do, right? Your first time do, I think very hard, okay? Yeah. Okay, let's do the last one here. Okay, so this one is to apply Runge-Kutta method. So here you want to do Runge-Kutta method, right? So that must be terrible, huh? So the step size h equals to 0.04. You want to apply it to this initial value problem. Here for a change, y double prime is d2y dt square, So that means here we don't use x, we use t as an independent variable. Okay, yeah. So this is you can see y double prime, right? So once again, this is a second order, yeah, second order equation. Y0 is like this, y prime 0 is like this, and we want to find y at this, y prime at this. Okay. Yeah. So let's go and see Runge-Kutta method. First of all, we need to rewrite. Okay, rewrite this. Okay, because this one is second order, right? So you see that we use the same method. Let y1 be this, y2 be y prime. Okay. Okay, the first equation is obtained by differentiating the first equation, the y1 equal to y here, right? And it will be the same. All right, so this one we did a few times already. So this will be my function 1. Previously, we'll write f1 x, y1, y2, right? But because here they don't use x, they use t. So therefore, I put f1 t, y1, y2. Okay. Now let's see the second one. Okay, second one, I'm going to differentiate y2. Y2, so I get y2 prime equal to y prime prime, y prime prime. All right, and what is y prime prime here? This one is easy. What is y prime prime? Can you all see what is y prime prime in this question? Anyone? Hey, class, you're still awake or not?
5
It's
plus
5 plus 2ty.
Yeah, that's right. Yeah, you just see from the question. Okay, your y double prime is this, right? And your y double prime is this. Okay, so we just get the 5 plus 2ty. Okay, well, now we are very familiar already, right? So let me straight away put y1. Okay, because y is just y1, right? So that's what we have. So this is what I have. Okay, so you see y2 prime equal to 5 plus 2ty1, and this will be my function 2. Right, and then the initial condition also rewrite. So this becomes y1 0, and this is my y2 0. Okay, all right, now I'm going to write down Runge-Kutta method. Now this one Runge-Kutta method, right? This is actually how you get to the next y. So I'm going to write down the y1, y2. Well, this is the simplest to write up. So this one sure everyone can write. Y1 n plus 1 is like this. Y2 n plus 1 is like this. All right, so these two formula will be used. This one used to calculate your y1. This one is used to calculate your y2. Okay, and then of course, the next thing is we are going to write down the A1, B1, C1, D1. There will be one whole page. And then the A2, B2, C2, D2 will be another page. All right, yeah. Okay, so A1, B1, C1, D1. They all depend on this function 1, right? So you realize that, oh, function 1 is just the last argument, right? Okay, A1. A1 is like that. Okay, so very easy. Function 1 is just the last argument here, right? Yeah. So just like that. Okay. Then B1, B1 actually is like this. Now this B1, let me show you my Runge-Kutta method. Runge-Kutta method should be before this. Yeah. So now everybody is looking at the BI, right? Yeah. Yeah, this is my BI. Okay. So this is my F1, and then this is what I have, right? So function 1 means equal to the last argument, right? So over here, this is the last argument. Okay. And then I come to C1. Now C1 is just like that. Okay, you can see the CI here, right? Yeah. Now, class, let me ask you, the B and the C, can y'all see that it's very much alike? The formula is very much alike. Can y'all see that?
I don't think so. There's one term that's different.
Yes.
I mean, it's very much alike. The only difference is that here is A, and see the A here, right? And then here
Yeah.
to E, right? So that means if we are lazy, then from here you can also tell already. The formula here, this one A2, right? So here it must be B2. In fact, it is. It's equal to the last argument here. No? Right, these are just our observation. And then the D1, well, you got your DI formula here, right? Then you just follow that. And this one also equal to the last argument. So you will be equal to the Y2N plus C2. All right, is it okay, class? Yeah, you can see that everything is equal to the last argument, right? And this one here, see? And this one here, that's why it is this one, right? Yeah, this one here, so it's this, and this is the one, the last one, so that's why it's equal to this. All right, so everything is using this function 1. Now we do function 2. Function 2 will change. In fact, for every question, your function 1 is the same, right? So, well, but function 2 will be different. So your function 2, 5 plus 2ty1. So you see it involves the first argument, the t, and the y1 is the middle one. The y2 is not used. Okay, so let's go and write down my A2. A2 is like that. Okay, you can see your A here, right? Yeah, A2 is like that. So this is the first one, this is the second one. So if I follow this rule, it will be h times 5 plus 2, the first one, times second one. So that's why it's this. I hope you see that. And when you go to B2, it's my B2, right? So this B2, this one, comma, this one, comma, this one. All right, so this is the first one, this is the second one. So I'm going to take 5 plus 2 times the first one times the middle one. Okay, and likewise for your C2, right? So this is the first one, this is the second one, right? So you find that I also apply this 5 plus 2 times the first one times the second one. All right, so you can see that I always apply this. And finally the D. Yeah, so this is your first, second, third, right? Okay, so I'm going to take 5 plus 2 times this times this. Okay, not class? So of course we write down all this, right? So this is called writing down the method explicitly. Okay, so if we are writing down explicitly, meaning what? Well, of course we'll get marks. Yeah, we'll get marks for all these things that we write down. Okay, yeah. So now we write down all the formula for our calculation already. So now we're going to set up our table. See, where's our question? Our initial value is 0. Okay, initial value y 0, y prime 0, right? So that is why our t0 here is 0. Okay, then you keep on adding the h. This is your point 12. So you need to stop here, right? So this is your initial y prime. And then you see all these all blank. Well, you need to go and calculate the first row. Okay, this one is also the first row. So like that is called first row completed. And of course, when you do your A1, A2, B1, B2, all that, where you get the formula from? From all this. Then you see your A2, B2, C2, D2, right? Your A1, B1, C1, D1, right? And in all this formula, your n value will be 0. Because here you are in this row, right? So your n here is 0. Is it okay? Then after that, I clicked the wrong thing. Then after that, then you want to get these two values, right? This is your y11, this is your y21. Go and look for your y1 formula, your y2 formula. Okay, so this one done already. Then after that, same thing. Go and complete the row. So you can see that actually it's like a very systematic process, right? Yeah, very systematic. Okay, so after you've done this, Then you do here, okay? Then go and complete the row again. Complete. Yep. Go and complete the row. Okay. And finally, you can get this. All right. Now this one no need because you are not getting the next point, right? Yeah. So you just stop here. All right. So this is this value is your y at 0.2. This is the value y prime at 0.12. Okay. Is it okay? All right. Well, anyone completed this question? Anyone or not? Okay, so well, this class doesn't surprise me. Previously, there are some people, they tell me that wow, they really complete this. You know, wow, that one is really, really surprising. Okay, class. Well, maybe you don't have such patience to do until here, but at least class, you know, for your practice, you try to do until here. Yeah, you try to do until here. See whether you are able to do until here or not. Okay, right or not? Okay, so well, we completed the tutorial. Yeah. Any questions?
Prof, can I check with you for examinations? Higher order ODE is only up to m equals to 2, right? And not more than that.
M equal to 2.
Yes.
Well, I mean m equal to 2 is what inside our tutorial, inside our lecture notes.
Is there any chance where you come out like m equals to 3 or even higher? Because this one is already pretty what do you call it, long-winded. But then the questions for, I believe, is m equals to 3 will be way worse lah.
Yeah. Of course, for Runge-Kutta, if you have m equal to 3, that will be terrible. Yeah, this one I agree with you. Runge-Kutta, if m equal to 3 will be terrible. Maybe well, if m equal to 3, you can imagine, you've got y1, y2, y3, a1, a2, a3, b1, b2, b3. Sure, you got imagination one, right? You can imagine, you can imagine, then that's very good, law.
But for this case, will the examination actually come out such kind of question?
And if I'm crazy, then yes, law.
Most examinations.
I think I'm not yet so crazy, So for Runge-Kutta method, I think y1, y2, y3. Wow, I want to do d1, d2, d3. I think quite hard, quite hard. Quite hard. Okay. Yeah, class. So that's all for tonight. Sorry, I overshoot about half an hour. So next week is a recess. Okay, what a relief, right? So everyone recess, what do you do? What do you do during recess? I think everyone need to revise. Okay, you need to revise because you want to prepare for your assignment, for your quiz, right? So when the assignment is open, don't straight away go and do. Don't go and do without preparation. So you better prepare first before you go and do assignment. All right. Well, I have some OASIS practice questions, right? So maybe y'all can do some practice questions first before we go and do assignment, before we go and do quiz. Now, practice questions, there are quite a lot. So you may not be able to practice all, right? So I suggest that maybe every topic, you just practice 1 or 2. Because otherwise you may not have time to practice every topic, right? So just practice 1 question from each topic. So at least that gives you some practice. Okay, now class? Okay, right. So next week is a recess. So I'll see you after recess. And everyone look out for my emails. Okay, now class, good night.
Thank you.
Okay, thank you. Bye-bye.